So the last part we're going to take a look at is from 4.1, part 2. And this is going to look at solving right triangles. Okay, so what we're going to be looking at is when we have a triangle and they don't give us all the information, we have to figure out what they don't give us. Okay, whether it's some sides that we don't know or some angles that we don't know. I just want to make sure. So that's what it means when you see the directions that say solve, and it gives you a picture of a triangle. That's what you have to do. Find all the sides and all the angles. Now, there's one thing we're already going to know in every triangle because of the kind of triangles we're working with this week. We are working with right triangles. So we automatically know that every angle or every triangle is going to have an angle that's 90. So we already know that. In addition to knowing that we have a 90, I have to give you two other pieces of information. Okay? Depending on what other pieces of information I give you, that's going to control how you find what you don't know. Okay? But I have to give you two other pieces of information. I can either give you one of the sides that you don't know and one of the other angles, or I can give you both of the sides. Giving you both of the angles wouldn't help. Because if I told you I'm thinking of a triangle and the angles, this isn't a right triangle, but it's a simple one to think about. The angles are 60, 60, 60. They're all 60. That's an equilateral triangle. It'd be impossible for you to know the side lengths because you could have a really small equilateral triangle or you could have a really big one. If all you know is the angles, you don't have anything that tells you the size of the triangle. So no matter what, you have to know at least one side, always. And then in addition to that, I can either give you the other side or I can give you one of the other angles. How you finish the problem is a little different in each of those cases. So what we're going to do is, if we don't have a sketch, we'll make it. Because we got to be able to see what's opposite, what's adjacent. So for a lot of people, it's easier if you just can look at a picture and visually see what's opposite and adjacent. Once we make a sketch, off to the side, I'm going to put everything in a table. And the table is just to organize all the information. There's a lot of information. You're going to have 3 sides you have to write down and 2 angles. You don't have to find all of that, but we want to put it all in one area so all our information is organized. All right. Remember, when we are labeling sides of a triangle, we're going to use the English letters A, B, C. A and B are going to be the what? Legs, yeah. And we want those as the legs. C is the hypotenuse. And what do we call the angle that's across from side A? What are we going to use for a name for that? A lot of times we use theta as a Greek letter when we're representing just a single angle by itself. But we've got 2 angles to represent, so we use 2 Greek letters. And theta is not one of them we use in this case. You could, we don't.
Alpha and beta.
Alpha will be the one across from A, and beta will be the one across from B. All right. So there's the information. What case is this? Are they giving me a side and an angle, or are they giving me 2 sides?
Side and angle.
Right. We should know right away what they're giving us because you've got a Greek letter and we know the Greek letter is an angle. Okay. All right. What's first thing we want to do with that information?
Make a triangle.
Yep, make a triangle. Again, how you face your triangle, that doesn't matter. I always tend to do it like that. I don't know. That's what I do. Right. And we're going to label it, and then we're going to fill in what we can. Where you put A and B, you can make that choice right now. If you want to switch A and B, that's fine. It's just once you put A and B, then we have to make sure we put everything else in the right spot. C has to be the hypotenuse. Alpha has to go across from A. Beta has to go across from B. Okay, that's the diagram that I'm going to use for pretty much every problem we do. All right, now let's fill some stuff in. So we know that side is 2, and we know alpha is 40 degrees. All right, so now I'm going to put all of that information in the table. I put my 3 sides on the left. I put my 3 angles on the right. Okay, I filled in what I knew. B is 2, alpha is 40, and I put boxes around everything I need to figure out. Okay, so when we're done, this problem has 3 answers. If it was a multiple choice answer, you pretty much just have to pick the right choice. If it's a short answer, then you can get credit for each part you get right. Right? So if you get one part right and the other part wrong, you won't lose all the credit. All right. Now, the way we're going to solve this problem, we can find anything that we want first. All right. When you don't have a 90-degree angle, then things get a little different. Okay, so we'll talk about that in 2 weeks. But when you do have a 90, you can find anything you want first. What do you think would be the easiest thing to get first here?
Beta.
Yeah, I would get beta because you already know 2 of the other angles. We all know that you're going to add up to 180, so we should be able to figure out what beta is. What's beta going to be? 50. 50, yep. Okay, so now we know beta is 50. I'm not going to label it in the diagram because I want the diagram to only have information that was given. I don't want to accidentally use this 50 to find anything else. Why do you think I don't want to use the 50? I want to stick with using, I'm going to need to use an angle here, but I want to use the 40, not the 50. Why? Yep.
So like in case you get the angle wrong,
Right. Well, what would happen if it's wrong?
then the answer is wrong.
Yeah, then everything else is going to be wrong. Okay, so if you use the 50 and it's wrong, then everything you use it for is also wrong. So the idea here is don't use any information that you calculated to then find something else. Always go back to what was given. Always. All right, so now what we want to do is pick a trig function. Because we're going to need the calculator, I only want to use trig functions that are on the calculator. Sine, cosine, and tangent. Okay. So those are the only 3 trig functions we're going to be working with today. To figure out which trig function I need to use, either sine, cosine, or tangent, I'm going to look at my diagram, and I'm going to ask myself first, which letter do I want to find? Okay, so what do we want to do next? A or C? Which one? A. Okay, so we're going to do A. So I'm going to circle what we want to know, and I'm going to circle the 2 things that were given. What we need to do now is label the positions of the 2 sides that we circled. And by position, I mean opposite, adjacent, or hypotenuse. All right. Let's start with A. So from the perspective of the 40, okay, that's your reference point. What is side A? Yeah. That is opposite. And from the same reference point, what is the side that is 2 units long? I mean, I know it's B, but I want the position of it, not the name of it.
Adjacent.
It's adjacent. So because we chose to find A, finding A involves the opposite and the adjacent. There's only one trig function out of the 3 we're using today that has opposite and adjacent in it. Is it sine, cosine, or tangent? Yep. tangent. Okay? So every problem that we do is going to have a trig function, an angle that we fill into the trig function, and then a fraction on the other side. So trig function, angle you fill in, and then a fraction on the other side. What's the angle that we're using in this problem? Yep, the 40. So we're doing the tangent of 40 degrees equals, and now think of what the definition of tangent is. It's opposite over adjacent. Okay. Opposite is A, and adjacent is 2. That's the equation that you set up to solve for A. Okay, now we need to solve for A. How would we get the 2 on the other side? So the A is by itself.
Multiplication.
Yep. And what would you multiply by?
2.
Yep, multiply by 2. So times 2 times 2. And we need to do that out and get the answer. But that's the length of side A. 2 tangent 40. And what is that? 40 what? Degrees. So that's another thing. Make sure we are in degrees. We already are. This entire section, well, this entire lesson is degrees. All right, so 2 tangent 40 gives me a length of, we're going to go to 3 decimal places, 1.678. Okay. All right, so that's the length of side A. Now, one thing you can check as you're doing it, the smallest angle should always be with the smallest side. The biggest angle should be with the biggest side, and then the middle angle should go with the side that's in the middle. Since 40 is the smallest angle, it definitely should be smaller than side B. And it is. It's a little bit smaller. All right, now we know 2 sides. What can you do when you know 2 sides to find the third one in a right triangle?
Use the Pythagorean.
You could use the Pythagorean theorem, but why do you think I'm going to say that's not a good idea? Okay, so this number is a decimal. It's not an exact answer. So if we use it, then we've already rounded it. It's not good to use something you've rounded to do more calculations with. Yeah?
It's also an answer that we got ourselves.
Okay.
From the diagram.
What's wrong with that?
It could be wrong.
Right, it's worse than even just being rounded, it just could be wrong. If that answer's wrong and you use it, then C is going to come out wrong. So we're going to go back to the 2 pieces of information that were given, the 2 and the 40, and this time we're going to find side C. So now we're focusing on what's circled in blue. Well, we haven't named side C yet, but we haven't written down its position. What's the position of side C? That's hypotenuse. All right, so now to find C, look at the side that you're trying to find. Look at the name of it. Look at the side that you know. And figure out which trig function has adjacent and hypotenuse in it.
Cosine.
Cosine, yep. So you write the trig function, leave room for your angle, and then leave room for your fraction. Okay, the angle is the same angle we used last time, 40 degrees. And cosine is adjacent over hypotenuse. So what's going to go on the other side? Yep. 2 over C. Now this one's a little bit different because the letter ended up in the bottom instead of the letter being in the top of the fraction. But we're still going to start out the same way. I'd like to get rid of having the variable in the bottom. So what could I do on both sides that would get rid of the C at the bottom? Yep.
Flip both sides.
We could flip both sides, but we're still going to end up with a fraction on this side if we do that. It's just the letter would be in the top, so technically you answered my question. But I'd also like to make sure we don't have any more fractions on this side when we do the next step. So what could I do that would get rid of having a fraction on the right side, and it would get rid of the c in the bottom? Let me phrase it that way.
You multiply both sides by c.
Yep. So we're going to multiply both sides by c. So now we've got c cosine 40 equals 2. And now we want to get this by itself. So we need to put the cosine 40 on the other side. Okay. How would we get c by itself and move cosine 40 to the other side? Yeah.
Division.
Yeah, I'm going to divide. So divide each side by cosine of 40. We're not even going to figure out what the cosine of 40 is. Okay, we'll type it in on the calculator, but we're not going to round that off. Okay? Not till the very end. So our final answer is c equals 2 divided by cosine 40. Look at what you started with and look at what we ended with. We can skip that step in the middle and basically go right to the end. Does anybody notice what happened inside the green box to turn it into what's in the blue box?
Just flipped it, basically.
What do you mean flipped it?
From multiplication to division, basically. That's what it looks like.
Okay. Anyone else? Yeah?
You swapped c and the cosine 40 degrees.
Yeah, we swapped the c and the cosine of 40. Those two things switch places. And that works not just for trig, but that works anytime you have something like, anytime you have something with a number on one side and then a fraction with a letter in the bottom on the other, you can always switch those two things and get your answer. That trick always works. If you forget that, you can do what we did in this middle step every time, but it's quicker if we just remember to switch them now. All right, so now let's take that in. Again, we're never going to figure out what the cosine of 40 is in this problem, because I don't really care what it is. I care about 2 divided by it. Right? So that's all I'm going to figure out. So it's 2.611. And that is C. And it came out to be the biggest side, which it should, because it is the hypotenuse. If it didn't come out to the biggest side, something's definitely wrong. All right. Any question on that? Now, if we want to double check that we did it right, we could check it with Pythagorean theorem. All right. We could see, let's do 1.678 squared plus 2 squared. Gives me that. And now let's check what c squared is. And if we did it right, what should c squared come out to?
6.81.
It should come out to 6.81. All right, so when we did it, we got 6.8156 and then 6.8173. Why is it, it's supposed to be equal. Yeah?
Because we rounded A and C.
Right, we rounded. Okay, we rounded to 3 decimal places, which is pretty good, but it's still, bless you, it really only comes out the same to the 2nd decimal place. Right. But that does confirm that we did it right. Okay. Any questions on that one? Okay, let's try this one. So this time they're giving you the information in a table right away. Okay. Is this the case where they give you a side and an angle like the last one? Or is this one a side and a side? Yeah, it's still a side and an angle. Yep. Okay, so we got our table. Last time we did this before the table. Now we're going to do it right after it. But what do we always want to do as our first 2 steps? Make a table and draw it out. It doesn't really matter which one you do first. Also, does it matter which way my triangle faces? No. If you want to draw it this way, that's fine. What's important is what is across from what. That's what's important. Okay, so A we know is 6. B and C, we don't know. But beta, we know is 20 degrees. I think I already said this, but everything's degrees in this lesson. All right. Since we don't use anything that we calculate to find what's in those boxes, you can do anything you want in any order you want. Okay, so what do we want to find first? Yeah, I generally I do the angle first because it is the quickest. What is alpha going to come out to?
70.
70, yep. Remember, alpha and beta, we learned yesterday, are complementary. They have to add to 90. 70 and 20 do. Okay. So, we have a choice now. When we use a trig function, we always need to reference an angle. That's our point of view. Which angle should be our reference point in this problem? Alpha or beta? Yeah. So we should use beta because it was given. And we definitely want to use the 6 because that was given. And even if we haven't decided which one we want to do next, we should probably label the positions of everything. Okay. So what position is side A? That's adjacent. And what position is side B? Opposite. And side C. Okay. So now we're ready with our labels for whatever side we want to find. Do we want to do B or C next? B? Okay. So we're going to find B. You can circle that if it helps you to visualize what's going on. So the side that you want to know is the opposite. The side you already know is the adjacent. So you need to figure out which trig function has opposite and adjacent. Tangent, yep. Okay, so remember the trig function? The argument that you're plugging into the trig function, it's not multiplication, it's what's being plugged into it, like what you plug into a square root, and then your fraction. Okay. Can anybody read to me what my whole equation is going to be once I set it up?
Tan 20 degrees. B over 6.
Yep. B over 6. And to get B by itself, what do we do on both sides? Yep. We multiply by 6. There you go. So that's B. Okay. Before I type it in, I know that it's going to be smaller than 6 because this angle is smaller than that angle. Okay. So if it comes out bigger than 6, then something is definitely wrong. Okay. So let's do 6 tangent 20. It should come out quite a bit smaller than 6. Yeah, 2.184. Okay, so that's B. All right, we got two sides. What do we think? Pythagorean theorem to get the third side? No? Why not?
B might be wrong.
Right, B might be wrong. Even if it's not wrong, it's a decimal. You don't want to use something you've rounded to then figure out something else. All right, so let's find C. So we're going to have a trig function, an argument, and a fraction. Okay, so now to find C, look at the pieces of information we're going to use. Adjacent was given. Hypotenuse is the unknown. Which trig function has adjacent and hypotenuse? Cosine. So, cosine of 20 degrees equals adjacent over hypotenuse. It's the same type of fraction we had when we found B. Just multiply by, no, I'm sorry, no, it's different. The 6 is in the top. So this is the one where, how do we get C by itself? Yeah, we swap it. C and cosine 20 switch places. Again, why that works, we just did that in the last problem. So I'm just going to use that from now on because it's faster. Okay. And C, what do we know about C before we even type it in?
It's larger, larger.
It's larger than 6. Yep. And another thing about a triangle is any two sides added together have to be bigger than the third. Any two. So if you add these two together, you get 8.184. This side couldn't come out to 9. That'd be too big. If it came out to 9, you'd have a triangle that maybe looked like that. The other side would be too long. Okay? So it's got to come out to be more than 6, but it's got to be less than 8.18. All right, so it gives me kind of an idea if I'm on the right track. Let's see what we get. It's exactly between what we said it had to be. 6.385. Now, I generally don't check it with Pythagorean theorem. If you had time on the test, you want to make sure you got it right, that would be a good idea. But it's not necessary. Any question on that? All right, so that's another side and an angle. All right, let's look at this one. Is this one giving me a side and an angle, or two sides?
Two sides.
2 sides. Okay, this is different. Okay, so there's a few things we're gonna do different here. Last 2 problems, we found the angle right away. Well, we could do it, but can we do it quickly in this one? Like in our head? No. Right? You don't have 2 angles, so you can't just add them up and subtract from 180. You can still find it. It's going to be a little more work to find the angle. But this time, the side is going to be pretty easy to find. What could we do? Well, let's draw it, and then we'll talk about what we could do to find C. So let's put A, alpha, B, beta, and C. So there's our diagram. What could I do to find C?
Pythagorean theorem.
Yeah, why do you think I'm okay with using it when I wasn't before?
Because you have both A and B that's already given to you.
Yeah. You're going to be plugging in 2 things that were given. That's fine. So let's use Pythagorean theorem to find C. Now, yesterday, we left answers with square roots in them when we were doing like all 6 trig functions. Today, if we get a square root, we'll round it off. Okay. So b squared plus b squared equals c squared. Okay. What's 3 squared?
9.
And then 2 squared?
4.
And what's 9 plus 4?
13.
Okay, so the hypotenuse is 13 squared. Well, the hypotenuse squared is 13. So how do I get rid of the squared? Take the square root. Yep. All right, so we take the square root, and that's going to give us what we're going to use for C, and we will round it off. 3.606. Okay, make sure you round properly. 606. Okay. So now we've got C. Okay, one thing that is the same here is you can still choose what you want to do. There is no specific order you have to follow. So what do we want to do next? Alpha or beta? Alpha? Okay, so we'll find alpha. So like I've done before, I'm going to circle everything just to kind of draw my attention to what I'm using. And because we chose to find alpha, that is our reference point. Okay, so from alpha, what is the side that's 3 units long? Opposite. And the side that's 2 units long? Adjacent. Now, I could label C as the hypotenuse, but I know I'm never going to use it because it's not something that was given. So why waste time labeling something I'm never going to use? Right? I'm only going to use the opposite and the adjacent. All right, opposite and adjacent tells me I'm using which trig function? Tangent. And it's the tangent of what's going to go inside my parentheses. alpha. Tangent of alpha equals, and how about on the other side?
3 over 2.
3 over 2. Okay, what's different about that compared to all the other trig equations we've set up so far? Yep.
The variables on the other side.
Yeah, the variable is not in the fraction on the right, it's in the argument to the trig function. Right? That's kind of like having a variable inside like a square root. Okay? The only way to get rid of this square root is to do something that cancels out square root. That's the opposite of square root. Right? No add, subtract, multiply, or divide is going to get rid of square root. The only thing that gets rid of square root is squaring, another function. Same thing here. No add, subtract, multiply, or divide can get rid of tangent. The only thing that can get rid of tangent is something that cancels out tangent. And we learned about that on Monday. Yep.
Arctangent?
Yep, we have to do the inverse tangent. So the correct word is we're going to take the inverse tangent. There's no multiplication happening here. We're just plugging this entire thing into the inverse tangent. So take the inverse tangent of what's on the left. And I don't have a lot of space. But you also have to take the inverse tangent of everything that's on the right. Now, inverse tangent and regular tangent will cancel each other out. But technically they only cancel out if this angle is between two certain numbers. What did we say? I forget if this was formula 6a or 6b. It was one of those yesterday. What did we say that that angle has to be between in order for these two to actually cancel out? Yep. It has to be between negative 90 and 90. Now, I don't even know the answer to the problem yet, but I guarantee you that this is between negative 90 and 90. How do I know that? Yeah?
Because one of them complementary angle.
Right, it's a complementary angle. So by definition, it has to be between negative 90 and 90. So it is safe to cross those two things out. They will cancel. And now we get alpha is approximately, and how do I get inverse tangent on the calculator? Second tangent, and we're going to do 3 over 2. And that gives me an angle of 56 point, well, this time I'm just going to round to 2 decimal places, 56.31. Okay, now if I was taking some kind of time test and I had to get done real quick, I only had like 10 seconds left, I would just do 90 minus 56.31, because we know it's complementary. Hope I got the 56.31 right, and then that would be the other answer, 33.69. But let's just keep that number in mind, and let's find beta the same way we found alpha. Okay. Subtracting that from 90 is not the best way to do it, because if you get that wrong, then you're going to get beta wrong. Right. So let's find beta. And let me circle everything we're going to use. Beta, 2, and the 3. We just switched our angle. Okay, this is the first time we've ever done that. What's going to happen now because we switched the angle? Yep.
The opposite and adjacent.
Right. These names don't apply anymore. You switched your reference point. So now, beta, if we look at what's opposite, it's 2. And what's next to it is 3. So when you switch your reference point in the problem, which you do when you have side-side, opposite and adjacent switch. But even though they switched, we're still using what trig function? Yeah, we're still using tangent. I'm not going to say every side-side problem is tangent. It's only tangent because I didn't give you the hypotenuse to start the problem. That's why. Right? But if I had given you the hypotenuse, you wouldn't have used tangent. You would have used sine or cosine. Right, but we're using tangent. Right, and we're finding beta. So fill that in. And what's going to be my fraction on the other side? Yeah, 2/3. Now I want to get rid of the tangent function. So to do that, I need to use another function. And what function am I going to use? Yep, the arctangent or inverse tangent. And the correct way to say it is you're going to take, not multiply, you're taking the inverse tangent of what's on the left, and you're taking the inverse tangent of what's on the right. There is no multiplication anywhere on the board right there. None. Okay. Those cancel out as long as the angle is between -90 and 90, but I know it is. So now, let's type it in and see if we get 33.69. If we do, that means we would have gotten the same answer 2 different ways. Pretty sure we're going to be right. Yep, it's 33.69. Okay. Oh, I didn't put my answers up here. Oops. So 33.69, 56.31. There we go. Okay. Any questions on that one? So that's the case where they give you a side and a side. So when they give you a side and a side, you have to use inverse trig. That's the only time you use inverse trig, when you need to solve for an angle. And I've mentioned that several times. Inverse trig finds an angle. In the first case, you don't have to find an angle. Right? You can just add up and subtract from 180, so you don't have to worry about inverse trig. Anybody have any more questions about the side-side case? Okay, what would be different on this one is they're giving you the hypotenuse, so it would not be a tangent problem. Okay. Sines and cosines. All right, let's try this one. So it says you're going to lean a 20-foot ladder against a house. The angle between the ladder and the house is 17 degrees. I want to know how high the top of the ladder will be leaning up against the house. Well, it's a 20-foot ladder, so isn't the ladder going to be 20 feet high? No?
No.
Why?
I can study the hypotenuse.
Yeah, it's the hypotenuse. The ladder's not, it's not vertical, right? You can't, that wouldn't be good. So it's not vertical, it's on an angle. So it's not going to reach 20 feet up. It's not much of an angle, right? So it's still going to reach very high, but it's not going to be 20. So what do you think would be good to do with all that information? Yeah?
Draw it.
Yeah, let's draw it. So reading that word problem, what's something important that's in our drawing? Yeah?
What would be the ladder?
Okay, the ladder, that's going to be an important object. What else? Yeah? Well, the angle is more of a math concept. That'll just happen when we put the objects in the picture. So I'm thinking just objects right now. So the ladder, what else? Yeah?
The house.
The house, and there's one more very important thing. Yeah?
The ground.
We need the ground, yeah. So we've got the ground. Okay, we've got our house over here. And we've got a ladder leaning against the house like that. All right. So they didn't say anything about the house being crooked, so we're going to assume the house is built correctly. It's perpendicular to the ground. And what do we know that we can label in that diagram? Yeah.
The ladder.
The ladder, how long is that?
20 feet.
So the ladder is 20 feet. That's from there to there. Yep, the angle where?
Up on the top, right next to the house.
Right, between the ladder and the house. The other angle they could have given you is between the ladder and the ground.
Yeah.
Right, they didn't. And we don't need that. But we do need the angle between the ladder and the house. All right. And now it says, how high will the ladder reach? So what is it that if we look at this triangle, what is it we're actually trying to find in the triangle? The height. So pull that off, you're trying to find the height of that triangle in red. So temporarily, we just call it A. And now let's see if we can find it. Okay, here is our angle. How are we going to figure out what trig function that we should use?
You can find the angle pretty easily, the first step.
Well, they're not asking what the angle between the ladder and the ground is. So yeah, I agree, we could find it very easily, but they're not asking for it, and we don't need it. Yeah?
You can find A.
Okay, we do have to find A, and how are we going to figure out what trig function we need? Yeah?
Hypotenuse and adjacent.
Okay, so let's label our sides. The position of 20, it's hypotenuse, and A is adjacent. So based on that, what trig function are we working with? Cosine. Okay, what's my angle? 17. Now that I know that's a number, I know that I'm definitely not going to use what in this problem?
Inverse trig.
I am not using inverse trig. Inverse trig would be if you didn't know the angle. Okay, we know it. Okay, so cosine is 17, and what goes on the other side? A over 20. Get rid of your 20. Multiplying, and that is how high the ladder is going to reach. So it's still going to be pretty high, but it's not going to be 20 feet. It's about 19.13 feet. Anybody have a guess at what angle you'd have to put the ladder at so that it only reached half as high as it is? So if it only reached 10 feet? Yeah? A lot of people think if you just put the ladder at a 45, then it will only reach up half of its length. Well, if you try that, it actually still reaches up very high at 45. It reaches 14 feet. You'd have to put it all the way at a 30-degree angle, which wouldn't be practical unless maybe you had some kind of thing anchored into the ground where it could lean up against it and it wouldn't slide, because that would be a very steep angle. But yeah, if you put it all the way at a 60-degree angle up here and a 30 down here, if you look at what happens when you plug in 60, that's when it would finally be only half as high as it is long. A lot of people think 45 because it makes a nice triangle. Yeah. Okay, so any questions on that? All right, so that finishes up right triangle trig. So tomorrow there'll be a review worksheet. It's mostly just going to cover section 4. It might cover a little bit of 3.1, but I think it's mostly 4.1. So solving triangles and doing the 6 trig functions. All right. So you've got a good amount of time today. You got about 20 minutes. So that's the homework. It's all odds, but it skips around a little bit. Just a reminder too that I will be here after school tomorrow if anybody needs extra help. And progress reports close next Friday, so this is the last week of academics before they close. If you have anything you need to get done, make sure you get that wrapped up before progress reports close.